So we've already graphed a couple of absolute value curves, but let's just start getting used to the shape of them. Not quite lines. When we don't know anything else, we probably want to just take a table of values that's centered around 0. So what do we do? Let's see. Absolute value of 0 plus 1 is 1. Absolute value of 1 plus 1 is 2, 3. Okay, so the positive ones, those are easy. What about negative 1? Well, the absolute value of negative 1, and then add 1, is 1 plus 1. It's not negative 1 plus 1. So this doesn't go back down, it comes back up. And then negative 2 absolute value is 2 plus 1 is 3. If we plot these points, so we have, let's see, negative 2, 3, negative 1, 2, 0, 1, 1, 2, 2, 3, and it will keep going. Once you've found the turnaround point for an absolute value curve, you can just plot points out to the edge of the graph paper. Plot points, don't just, if you draw something that goes like this, well, you won't see it. If you draw something that has a slope that's not just a beautiful slope of 1, you will, I'll mark it wrong. So, and you'll have points off on the test. So make sure that you got that correct. The description in words is this is the absolute value curve up 1. So this plus 1 moves you up 1. The domain is all reals because you can plug any number into the absolute value. You can't get any number out. The range is only from 1 on up. Set builder notation will say y such that y is greater than or equal to 1. Okay, remember that the y and the such that is red, y such that. It's not a 1, it's not an absolute value bar itself. It's a such that symbol. Okay, so what does this one look like? If I center this around 0, 0 minus 2 is negative 2, absolute value is 2, 2 minus 3 is negative 1. 1 minus 2 is negative 1, absolute value is 1 minus 3 is negative 2. Let's see. 2 minus 2 is 0, 0 minus 3 is negative 3. Does this one keep going? No. What is 3 minus 2 is 1, minus 3 is back to negative 2. This one is centered around x equals 2. And in fact, we will find out that what you do is you take the part inside the absolute value and set it equal to 0. And we call that center point a vertex. So I'll just make a little note up here that this is called a vertex. And it turns out the vertex is at 2, negative 3 here. So 2, negative 3, and then height of negative 2 on either side, height of negative 1, plot points all the way out to the edge. If you draw something that's not straight, it'll get marked wrong, and you'll have to redo it. Okay, so this is right 2 and down 3. And notice that x minus 2 gives you right 2. So but negative 3 does mean down 3. Okay. So what's the domain and range? Domain is still all reals. Range. Above -3. Okay, the next thing, the negative flips you upside down. So I'm going to set x plus 3 equals to 0, so it's centered at x equals -3. So when I build my table of values, I'll put -3 in the middle. If I plug in -3, I have absolute value of 0 is still 0, -0 is still 0, up 2, so plus 2. Absolute value of -2, let me just write one down. Negative in front. Don't deal with the negative until you've simplified what's inside the absolute value. -2 plus 3 is 1. Okay, so this is 1. And it's, if I do -4, it's also 1. So this -3 really is the turnaround point. I'll highlight it. That's where my vertex is. Okay, so left 3, and up 2, and upside down. I'm going to say upside down first, because that's the regular order of operations. Okay, left 3, upside down, up to -4, 1, -2, 1. And graph it. Mean, it's reals, range, since it's upside down, is below. So y such that y is below height of 2.